Hello, everyone. Hello, ladies and gentlemen. I'm Lawrence, and here comes to the final lessons. And so please wake up, don't sleep. You're going to graduate very soon, and the final lessons is about our GD880 engineering drive. Uh, it may be a little complicated if you don't have experience on such product or project. I hope after these lessons it will become simple to you. And the contents include product overviews and product features and selection guide, and final part is about applications. This is the GD880 product family. GD880 is a platform product and based on our more than 15 years experience and product accumulations. It is faced to the high-end market and widely used on the industries like pork and metallurgy and oil and gas, paper making, marine, and cements, chemical, centrifuge, and motor test. And here's the product family. There are single dry and multi-dry products. The single dry, that means one rectifier to one inverters. And multi-dry represents the we can use the rectifier and the inverter are separated, and we can use one rectifier and for multiple inverters and connected in common dispatch. For single dry, we can provide a single dry module and also the two quadrant VFD module cabinet and four quadrant cabinets. About the multi-dry, we have three types of rectifier: basic rectifier, regenerated, and active front end. I will introduce the difference later. And also the inverter unit and three-phase braking modules. And for all this module, we can provide a complete cabinet. And here's the control topology of this product. It adopts the common dispatch and the distributed control systems. Optical fiber is used between the control unit and power units, and the control unit has independent 24-volt voltage supply. And between the PC to the control unit, it has the standard Ethernet port. And it supports various communications between the controller and the PLC. And here's the control resource. It has three slopes for the extension, and it supports the remote extension. So maximum it supports up to 7 extension modules. And it has an Ethernet port for the PC software monitoring and configuration. And it has the STO and the master-slave interface is optical fiber. So we don't need to use an extension card like GD350. And it has SD card and also the battery for real-time clock. And support the extension cards like encoder and the input and output terminals extension, and also the communication. This is the operation panel. It is a high protection IP54, and it has USB Type-C interface. So we can use only a USB cable for the firmware upgrade. We don't need to use a RS-232 adapter like the low voltage drive. And the control unit support to, for the rectifier, we support up to 6 modules connected in parallel. And for the inverter unit, maximum is 10 units. So that we can realize up to 5 megawatts product. And then I will introduce the power units one by one. And this one is the single drive unit, GD880. Here's the single drive diagram. It includes AC to DC rectifier and the DC bus capacitor, and also DC to AC inverter. So it is a complete AC, DC, and AC variable frequency drive. It has a built-in DC pre-charge circuit, and there are 2 structure types. E3 to E12 is similar to our low voltage drive, and 11A8 is another size. The smaller single drive units has built-in braking units, and for high power we usually use 2 11A8 connected in parallel, and higher power we usually use multi-drive solutions. And here's the hardware composition of this single drive unit. It composes of the single drive unit and the control unit and operation keypad and optical fiber and keypad cable. And these are the necessary components. With this component, it is ready to start. And here's the selection table of the single drive unit, E3 to E12. And we have heavy duty, light duty, and nominal ratings. And here's the selection table of 11A8, this structure time, 400 watt and 690 watt. And high power we use 2 connected in parallel. And the second one is the basic rectifier. This rectifier using half thyristor and half dial. So it's half control. And for such rectifier, we don't need a pre-charged circuit. And we can provide 6 power and 12 pulse basic rectifier, and it has only one size, D80. And it has built-in input reactor and the DC fuse. And it uses the quick plug-in connector. It's easy for us to install and maintenance. And this diagram shows the position of the basic rectifier. AC input and rectifier, and then connect to the inverter. This is the hardware composition of the basic rectifier. The necessary components are rectifier unit and the control unit and the keypad and the optical fiber and the cables for keypad. And the selection tables for this 400 volt, 6 pulse and 12 pulse products. And we can see that the highest power use the six units connected in parallel, and the nominal rating power up to 3.6 megawatt. And the selection table for 690 volt and maximum up to 5 megawatt. And the second type of rectifier is a regenerative rectifier. It has the regenerative function and can realize the regenerated energy flow from the DC bus to the power grid. And such rectifier is suitable for the applications require the energy feedback and but no low harmonic requirements. And we use the input reactor as the filtering unit. And for the A8 unit, it's also quick plug-in terminals. And see this diagram on the rectifier using the IGBT. And this is the single line diagram of this regenerative rectifier, input circuit breaker and main contactor, and the filtering unit is input reactor and the rectifier unit. And the above part is a pre-charge circuit. This is necessary. And here's the hardware composition of this product. Rectifier unit and filtering unit. And pre-charge unit is also necessary, and control unit. And the voltage detection module is used for the input voltage measurement because we need the phase locking until synchronized. And the optical expansion module is used to connect between the voltage detection and the control unit. Here's the selection table, 400 volt and also 690 volt. The maximum capacity is using 6 rectifier units connected in parallel. And the third type of the rectifier is active rectifier. It is also called active front end. It is a little different to the regenerative rectifier. It's using the LCL filter as the filtering unit so that it can achieve the ultra-low input harmonic, less than 3%. And here's the single line diagram. The input filtering unit is LCL filter. And here's the hardware composition of this product. The only difference to the regenerative rectifier is on the filtering unit, and the rest are the same. And the selection table, we have 400 volt and also 690 volt. And for this active front end rectifier, we can provide maximum 10 units connected in parallel, so that we can realize maximum power is 6 megawatt for this product. And here's the inverter unit, GD880 we can see the diagram. It's a DC to AC inverter, and the biggest size, A8, has output reactor built-in, and because for the high power parallel, the output reactor is necessary. So the A8 unit has the built-in reactor. It's convenient for us. And here shows the position of the inverter unit. And besides the inverter unit, on the DC part, we can choose the DC fuse and also the pre-charge circuit and isolators for options. The necessary parts is inverter unit and control unit and the keypad and optical fiber and the keypad cable. This is the selection table for 400 watt. Maximum the maximum power we use 10 units connected in parallel. And here's the three-phase breaking unit, and it is modified based on the inverter units. But it has no the output reactor. And compared to our DBU dynamic braking unit, the power is much higher and the smaller size, and it uses the quick plug-in terminal and also very easy to install and maintenance. And we also have developed the liquid cool modules for this product. And currently it has only the voltage class 690 volt, and we have three types: diode rectifier, an inverter unit, and single drive unit. And each type have only one size. And here's about the structure product. Because the high power unit is using the quick plug-in terminals, such structure require very accurate designs of the cabinet. It requires the integrator to have the 3D design capability, and so this structure design is easy for our integrator to build their cabinets. The size is a little higher, a little bigger than the power units. For example, when we choose for this two units, you don't use the structure, the standard cabinet is only 600 millimeters. So when we use the structure frame, the size will be higher, become 800 millimeters. And in China, the EU industry, we have many users are using the old Siemens engineering drive 6SE70. For such a transformation project, we can provide the 70 frame to replace their modules. And here's a typical multi-dry cabinet, but it's not standard. We usually design according to different customers' requirement. For this cabinet, we have the control cabinet, the control unit, and the control panel is installed in this control cabinet. And the second cabinet is incoming cabinet. Usually the circuit breaker or main contactor or the isolator is installed here. And then rectifier cabinet and inverter cabinet and braking cabinet. And here's the standard cabinet size. The depth is 600 millimeter and height 2,000 millimeter without fan. And including fan, it is 2,140. And the width we have 400, 600, 800, 850, and 1,000 millimeters. Then the second part is about the product features. And it has multiple overload modes. And for the light duty overload, it is 110% for 60 seconds. And for the heavy duty overload, it's 150% for 1 minute. And it supports the fault derating function. For example, when we use 3 units connected in parallel, if one of the unit is broken, we can disconnect it and set some parameters, and then the rest 2 units can continue runs. And this product, every time we quote to the customer, maybe they feel the price is very high because the core components of the power unit are using the same grade as the components related to the top companies like ABB and Siemens. And the components have long line design. And so to achieve the reliability and stability of the product. And it supports the communication redundancy. We can connect 2 communication expansions at the same time and can be switched. We can select and switch. And about the full life cycle management, it supports 10 customers for clarification, processing, and real-time clock to ensure the accurate timestamps of the fault data. And also the black box supports 10 channels of data stored. And the main control unit has the built-in SD card, which supports the parameter upload and downloading. And DC pre-charge circuit and the isolator is optional. It can ensure that the faulty module can be removed and replaced without switching off the main AC power supply. And the A8 unit adopts the quick plug-in connectors, and the buttons have wheels, and we can directly push into the cabinet. And the cooling fan is drawer design, also very easy to replace. And besides the LCD operation keypad, the control unit has a standard Ethernet port for the laptop software to monitor and configuration. Because GD880 has thousands of function codes, it is difficult to communicate, to configure with only the operation keypad. So we have developed a special INVT workshop for this product. It has more function than the standard workshop. It supports the automatically search for the connection and debugging research, and also the online oscilloscope and support 10 channels waveform. And it supports the graphical free programming. And GD880 has many functions, but the functions are modular design. And we have the open data flow diagram in this workshop. So we don't need to memorize the function codes, the meaning of the function codes. When we commissioning, we only need to enter the data flow diagram, and it's very easy for the commissioning and set the parameters. And GD880 supports the parameter interconnection. This is called the BICO in the Siemens drives. It can realize the resource sharing and secondary development through the connectors. So for some non-standard requirement, we can use this BICO function to realize. No need to develop a non-standard firmware. And for the such GD880 engineering project, most communication is using the Profit bus and Profit net. And in previous products like GD350, our controller and the stator are fixed. Customer want to use our product, but without program their existing PLC, we have to develop a non-standard firmware. But for this GD880 products, we can easily configure the controller and also the stator to compatible with the existing PLC. And we don't need to replace the GSD file of the PLC. And it supports some process control for different applications. Like the belt conveyor or crane, sometimes we use the master slave control. And it supports the one key marker is easy for debugging, and also the crane control logic and brake control, and also the brake feedback and the zero servo function and cabin protections, etc. And the third part is about the selection guide. Here's the naming rule of this product, and the 1 in the end of the series represents the power unit, and the 6 represents the cabinet. We have 11 is the 6 single drive VFD unit, and 41 is the braking, 51 is inverter, 71 is basic rectifier, 81 is regenerated rectifier, 91 is the active front end. And here's the control modules. We have the control modules for inverter and the control modules for the rectifier and also the LCD keypad, communication cards like Profinet, Profibus, and can open, and optical fiber expansions for the regenerated and active front end rectifier, and PG cards for the closed loop vector control, and I/O expansions, and the detection modules, and the remote expansion module, and optical fiber. Here's the selection steps. Firstly, we have to understand what is the industry and what kind of application and what kind of equipment is using. And we have to get the motor parameters from the client. And then we will choose the power modules according to this information. And on the input side, we have different solutions, circuit breaker and isolators. And then we choose the control unit, keypad, and then communication cards according to the communication protocol. And if they are using closed loop control with the encoder, we have to choose the PG cards according to their encoder type. And the DC voltage module is for the DC-DC converter, and AC voltage module for the regenerated and active front end. And they have more input and output terminal requirement, or the motor temperature protection requirement. We also have to choose extension cards. And on the output side, we have, if there are long cable requirement, or we have to choose maybe output reactor or DU-DT filter or sine wave filter according to the cable length. And braking module is required for the dynamic braking requirement. And we can easily select the model from the catalog. Here are some cabinet models, and if client want to use only power units without cabinet, we can also find order list from the hardware manual of each product. And here is the configurator. I will show you soon. We can input some basic parameters, and then the table will show the model types. And the first part is about the applications. GD880 engineering drive is usually used on the end user industries like oil and gas. On the oil drilling, we are the first Chinese brand who have entering the oil drilling in this market. And in Russia, we have many applications like Gazprom and Rosneft, the top oil companies. And on cement industries, it's usually used on the equipments like rotary kiln and mills. And on iron and steel industries, it's usually used on the rolling mill applications. And last year we have a project in Russia. It is a 3 megawatt active front end rectifier, and thanks to our professional partner, Rosalcom, they have won the project in MMK steel plant. It is a top company in Russia. And on portrait, in the pulp industry, such product is usually used on different kinds of cranes, like the container crane and the RTG and RMG, and also AGV, automatic guide vehicle. And for the test bench, it usually requires the regenerative functions, and our active front end product it can meet such requirements. And on the paper making industries, in this year, our Russian professional partner, System Electric, have won the overseas first GD880 project on the paper machine and slitting machine. Yeah. And then I will introduce this project. And here's the project development process. First step, it is demand analysis. We have to identify the industry equipment and process flow and the technical requirements. And we design according to these requirements. And then production and factory inspections. And then we assist customers in site installation and commissioning and user acceptance. And we provide spare parts guarantee and fault analysis and repair service in product life cycles. And here's the paper project in Russia. And this year, this project is still implementing. And the end user is a paper making factory in Russia. There are 2 sets of GD880 36 regenerated multi-dry cabinets. And here's the technical requirements from the users. They require the multi-dry cabinet solution and some options like steel prints, lighting lintel, and the cabinet lighting, and disconnectors and pre-charge circuit for inverters. And also the cable length is quite long, so they use output reactor for each inverters. And Profinet protocol is used for this project. And here's the motor list, and they require the 4 quadrant running. So we choose the products according to these requirements. And we use a regenerated rectifier and multiple inverters connected in parallel. And each inverter has an output reactor, and also each unit has the Profinet card and also PG cards for the closed loop vector control. And there are many inverters units, so we have to make a layout for the cabinets. And we use in the plan stage, we use the Microsoft Visual, and we can easily use the component libraries for the cabinet layout so that we can provide the customer an initial cabinet size. And after we win the tender, and we confirm the technical agreement with the customer, and then they place the order, and after that our engineer will conduct the detailed design including the structural and the electrical. And the cabinet assembled in the workshop, and the factory inspection, and after that it will be delivered to the customer side and install and commissioning. And that's all for these lessons. And we all know that it is very difficult to promote for such a high-end market and high-end product is very difficult. But for such products, it has a higher technical barrier, and also we have fewer competitors and also more profits. So that we should insist on doing the difficult but right things. Thank you.